A very good evening from SAE India, Hyderabad division. We request all the participants to kindly keep your mobile phones on the silent mode or the flight mode before we start the program. This is Professor V. Uma Maheshwar, the chairman for SAE India, Hyderabad division. And today, March 4th, 2023, we have organized for a lecture meeting on a very important topic. And we have today with us the eminent speaker in the area of autonomous driving, Mr. Rahul Rajupalepu, who is the Vice President of Stellantis ICT Global Digital Hub, the Stellantis company. I'm very glad to inform you also that he is also the main committee member of the SAE Hyderabad division. We all know that the world is moving towards new technologies, and every day there's exponential growth in the technologies. And in terms of mobility, there is a new wave that is coming up in the arena of self-driving. And we all know that it's going to change the entire transportation system in the future. People like us, when our left hand and left leg were made free, and it is very easy for us to drive such vehicles in the city areas. Already in the global arena, we already have different levels of autonomous driving vehicles, autonomous cars, which are helping us to move from one place to other place, just like using the GPS codes from two location. There are robo-taxis already in use in several cities across the world. And also in India, we hope to get these vehicles on roads at the earliest. To know about what's happening in this arena, in the area of autonomous driving, autonomous cars, the global developments, and the potential future promising aspects that are going to happen in India in terms of technology as well as the deployment. I now invite the College of Engineering, Osmania University, and I'm also very thankful to the principal, Professor S. Venkatesh, and the head of department, Professor Chandrasekhar Reddy Garu. This is done in collaboration with Human Capital Development Center also, whose director is Professor Stevenson, sir. So, without much delay, I would like to request Mr. Rahul Rajupalepu, please come over and start the lecture. Welcome, sir.
How do I change to slides?
The global digital hub in India. In fact, he wanted a very brief introduction of him to the audience because the core intent of this lecture is to talk about the technologies. And therefore, I once again welcome, sir.
Thank you, sir. Thank you, sir. And thank you all the MC members and also the professors here. Thanks for the opportunity once again. And then thank you, students. So some of the content that you see and also what I'm going to present, I try to cover the breadth, not necessarily the depth, because you have a lot of your professors who are giving you a lot of depth. So we thought we will give you the breadth, that way you understand what are all the dynamics and then where we need to focus on where we are heading. So that's the intent of focus on where we are heading. So that's the intent of this lecture. Probably we'll keep it to about 30 to 40 minutes of lecture, and if you have any questions, I'll take it after that. So this is, so the topic today is fiction to reality. So that's the reason why I put that picture. So if you see some of the old James Bond pictures, you might have seen this picture, right? So where people sitting in a car playing on the straddle board. So this one, when it happened, so maybe you guys were not born at the time, the students, and some of us might be seeing that. So At the time we thought, okay, so is this really going to happen? But today, if you look at it, it's becoming a reality. I mean, so for the most part. If you look at the evolution of this, right? I mean, so the very first evolution of that happened in 1498. You won't believe this. That's called as a self-propelled cart. So, as sir was saying earlier, point A to point B, without a human intervention, if the vehicle is moving, that's autonomous. I mean, so from a definition perspective. So this was created in 1498. I mean, so that was the first one. I mean, I tried to search who created this, but I couldn't find. But in 1925 is when officially we can say the first autonomous vehicle was created. That was controlled by radio frequency, and that was created by Ford. In fact, Ford also created the first automobile in the world. I mean, so the credit should go to Ford. In 1966, I mean, so obviously I'm from Stellantis, so you would see some of our evolutions as well. So Citroen is one of our brand. We have created a car. It's the Citroen DS model that worked on a magnetic frequency. And so this required a lot of infrastructure behind that. I mean, so there would be magnetic cables underneath your chassis, and then there would be magnetic cables underneath the road. So that required a lot of infrastructure also along with it. Without human intervention, how we were able to move from point A to point B using this technology. I mean, so this was also at that time categorized as autonomous. But if you look at 1998, that's when the major evolution happened. So how many of you know CNN? Can any of you tell me what is it? Sir, of course you know. So I'm from the student's perspective. So convolutional neural networks, some you might have heard. I mean, so you've heard machine learning. One of the techniques in machine learning is convolutional neural networks. The invent of CNN actually changed the paradigm from an autonomous driving perspective. If you look at CNN, so CNN uses a machine learning algorithm called as deep learning. So deep learning, or it's also called as a deep reinforcement learning, this actually changed the whole way, because at real time, getting the data and then processing and then giving you the solution at that time was feasible using CNN networks. So that is when the real change happened from an autonomous perspective. CNN works on three principles. So it's called as SAR: state, action, and reward. When you say state, what does it state meaning? That describes the current situation of the car, and at that given time where it is, what it is doing. I mean, so this is what is the state of the car at that point. Then the action. The action describes what are all the various options that are available for the car to move around. I mean, so whether it should take a right turn or a left turn. I mean, so this is what is the action that will be given by the CNN algorithm to you. Then the third one is reward. Reward is basically at that time whether the decision that is given by your algorithm, is it really the right decision, and then how did your vehicle perform to that decision. I mean, so this is what is the CNN algorithm gives you as an output. I mean, so it's called a SAR. So this is when the major transformation started happening. But of course, you know, from 2009 onwards, there are multiple players who started getting into this arena, including some of the IT companies. I mean, so if you see Alphabet today, I mean, earlier Google also started getting into this arena. Then Apple also tried, apart from various other automobile manufacturers. I mean, so there are so many evolutions that have happened from 2009 onwards. I mean, so just to give you a landscape and also a history of this. So as per SAE, so which is what we are all part of, right? If you look at how the various levels of autonomy are defined, I mean, so if you see, a zero is called as no automation. I mean, so level 0, where there will be warnings in this particular automated vehicles. I mean, so there will be warnings. There is an automatic braking system that will be available for you, and then there will be collision alarms that will be coming to you. I mean, so this is what is called as the level 0. Level 1 is driver assistance. Driver assistance is predominantly works on the lanes on the road. I mean, so whether lane shift, right shift, left shift, then cruise control, adaptive cruise control. I mean, so if these features are available, we call it as level 1 autonomous vehicle. Today, most of the vehicles across the world are level 2. If somebody is claiming they are at level 3, it's not really. I mean, so there's only one or two companies which I will give you their names. Most of them are partial automation as of today, including your Teslas, including your Volkswagens, and including your Mercedes. Most of the cars are at level 2 automation. So what does it do? I mean, so it's basically assist you in the parking, highway pilots. I mean, so where you can go hands-free and then you can let the vehicle drive. So these are the features mostly that are available at level 2. This is where most of it. Level 3 is conditional automation. At this stage, from level 3 onwards, ideally speaking, the human intervention should not be there. I mean, so the car should automatically drive. But the only difference is in level 3, if there is an emergency, car will alert you so that the human can really take the control and then drive the car at that point in time. And so this is the only level where you have a mix of both automated as well as human interventions, only on need basis. I mean, so that's the reason why level 3. So level 3 is very tough. Even today, most of the companies are struggling to achieve. There are only 2 or 3 companies which I will tell you. Volkswagen, they claim that they have arrived at level 3, but as per SAE guidelines, they are still at level 2. I mean, so they have not achieved full level 3. The other company which is released their full self-driving capability is Tesla. So Tesla also claims they are at level 3, but they're still not at full level 3. I mean, so they're still at level 2. The third company which has actually achieved a large extent level 3 capabilities is Mercedes. So Mercedes, they call this as Drive Pilot. That's the feature that they describe as level 3. This is mostly having most of the level 3 features, but this is still under evaluation. I mean, so there is a lot of regulatory compliance that it need to go through before that can be declared as full level 3. I mean, so this is where we are today. Level 4 and level 5 we are at to achieve. I mean, so this is going to take a few more years or maybe another 10 years maybe. I mean, so if you look at current scenario today across the world, you are seeing most of it on the EV. I mean, so battery operated vehicles and carbon neutrality. This is become the major focus for automobile companies than really looking at autonomous. But people are still investing and then developing technology behind autonomous. But otherwise, at this point in time, most of the developments are on EV. So enables of autonomous driving, right? I mean, so from a technology perspective, I just want to cover a few. So there are 3 main areas here. The eyes of the car, which are your sensing agents or the sensors. Then the brain, which is what is the processing chips that you have. Then the heart. Heart is basically the control mechanism. And so if you want to compare in that way. So these are the 3 main things from human perspective which need to be replicated on an autonomous perspective, right? So if you look at most of the sensors, so the sensors are the eyes of the car. And you need to have a lot of sensors, and this technology today is predominantly on LiDAR technology, which is light detection and ranging. I mean, so LiDAR technology sensors are widely used across various cars today. I mean, so from an autonomous perspective. I'll go through the challenges in a bit, but that's what is your eyes of it. Then comes to your processing chips. For you to give a perspective, in today's car, for the most part, at least $300 to $400 worth of equipment is microprocessors on an average. And if you talk about highly automated car, it goes anywhere from $1,000 to $1,500. I mean, so on one car. I mean, so this is the amount of chips that are going into these cars today. What has happened because of the war? I mean, so why am I talking about the Ukraine war here is also to give you a perspective. The chip shortage today is actually affecting a big time the automobile industry, I mean, especially because of this dependency. That's number 1. Number 2 is the features that you see in car to car, model to model also differs. So there is no standardization across various brands. Everybody wants to offer their features as their unique selling features. I mean, so that's the reason why you would see this chip manufacturing is very cumbersome process. It takes a lot of time. Each chip need to be curated for almost 15 days on the silicon layers, and then layer by layer only you can develop. So, and the biggest producer of this is Ukraine. I mean, so we get almost 40% of the supply comes from Ukraine. Then Russia. I mean, so these are the two countries which are fighting, which are creating this raw material shortage, because of which we are also experiencing the delays in the chips, right? I mean, so that's another one. If all the automobile makers sit together and then probably identify the features and then standardize, to some extent, we will be able to mass produce, but otherwise heavily customized chips are produced, which go into automobiles today. I mean, so that's another challenge that you have. So the data, if you look at the data, as I said, I mean, so most of your CNN networks are machine learning algorithms. That means they need data, and they process that data to really come and then give you what is that the decision that the car need to make. This data today, there is no real-time data available. And so 90% of the data that we get today is in a simulated environment or a simulated data. That's the biggest challenge, because autonomous is not proven yet. You can't really put it on a road and then say, okay, so let it crash and then I'll get the data and then I will simulate it, right? I mean, so there is a lot of issues around that. I mean, so that's the reason why you get a lot of simulated data. With that simulated data, I don't know how many of you do machine learning algorithms in your classes. So we talk about what is the accuracy percentage, right? I mean, so even on the lab environment, we achieve 90, 95, 96, 98. I mean, so we confidently cannot say 100% our algorithms are working, even on our lab environment. So imagine this is like processing trillions of records on a real-time basis. I mean, so in that context, achieving that 100% accuracy is going to be very, very difficult. And from an autonomous perspective, you are playing with humans' life. I mean, so you need to be really very careful. I mean, so you need to really have that level of accuracy. I mean, so that is where this takes time. I mean, so the data simulation, getting that data for us to really get accurate results. I mean, so it takes a lot of time. The other thing is, because these IoT devices are giving the data at real time, you need to have that kind of a processing power. So in the past, everything used to be in a data center. You have a lot of servers which process all this data. But today, with cloud computing, a lot of that has moved to cloud. I mean, so at a real time, you can at least wherever you are, you will be able to get the data. Even that is not enough, because the latency here matters a lot, because the decisions have to be at real time in split seconds. So if you know edge computing, I mean, so edge computing is coming to a rescue for us to a large extent, because edge computing actually replicates the nodes nearer to the data, where you get the data. So in that context, edge computing is helping you a lot, but still a lot of work need to be done. I mean, so for us to really get that split second responses. I just want to give a couple of examples for you to understand how complex this is, right? If a human is driving, let's say we are driving a car, and then you are going at a certain speed in Osmania University Road, and suddenly a football or a tennis ball pops onto the road. So what does it tell you? I mean, so you actually brake. Why you brake? Because I mean, so there is an object. The second thing, your intuition, which tells you that if the ball is running around, there might be somebody, a kid or somebody who will be following that. I mean, so they might be coming just behind that. That's your intuition. But if you are actually depending on a program, what happens is for a program, there is an object which has come and then moved away. Then it's free. It tries to accelerate again. Then comes another object, which is a kid. And then the amount of time that you have to respond and then really brake might really result in a fatality. I mean, so this is how that intuition, if you can bring into the computing power of your autonomous vehicles, that's when you will really achieve successful results. Which today, that's the reason why level 2 and level 3, where we say humans are involved. I mean, so humans are going to take control. That's the reason why that's more safer. But nobody has really wanting to experiment saying, okay, full autonomous at this point in time. Okay. So the other thing I just want to cover in the same scenario, right? So If you go to our Himachal Pradesh or any of these areas, so you will see these uphill roads, which are predominantly a single vehicle roads. The autonomous vehicles depend on sensors, as I said. The sensors depend on road markings. So you will have this road marking on the left and then road marking on the right. So let's say one vehicle is going up the hill and another vehicle is coming down the hill, and both are autonomous. So this question we ask a lot of the candidates who come for interview. So how do you program this scenario, right? So if you are a human, so the human guy will take a little bit of right deviation. He will cross that white mark and then he will go to, and then that guy also will cross a little bit. They adjust and then they cross over and then they move. If it is an autonomous vehicle, it will not cross that line because it is programmed that way. So you are in a deadlock situation. I mean, so this vehicle will not move, this vehicle will not move. You are in a deadlock situation. So these are all the challenges that we need to face. And what if there is no lane marking, right? The car will go indefinitely onto the left till it finds a line, which means it's falling down somewhere. I mean, so these are all the challenges that we have in terms of fully autonomous vehicles. So what technology imperatives to realize higher levels of autonomy, right? I mean, so if you look at what are all the different technologies that are going to help you. So as I said, sensors in the past. If you go into developed countries or even Western countries, the weather conditions are very unpredictable. I mean, so you will have snow, you will have, if you go to Middle East, you will have the storms. I mean, so if your eyes are blind, I mean, so basically if the snow is covering the sensor, you can't drive. I mean, so similarly, the vehicle will not get that data from that sensor. Whereas the vehicle in an autonomous way is getting data from all directions. Even if 3 or 4 directions are blocked, the eyes are blind. I mean, so from a car perspective. So weather resistant sensors even today is a challenge. I mean, so we are not able to really get there. I mean, so we are still trying on various options from an industry perspective, but we are still having that fail-safe sensors is still a challenge as of today. Accurate data and then accurate training algorithms, as I was mentioning, you need to get that data at real-time processing and then having that highly accurate results is again a challenge in the current environment. Electrical and electronics equipment that goes into the car and the process software architecture. I mean, so this requires a complete overhaul as of now. I mean, so these are all the areas that we need to really look into. Edge and cloud computing, as I was saying, I mean, so edge computing is probably to our rescue, but it requires enterprise applications which receive this IoT data at real time and then process. The other challenge is because of these IoT devices giving so much of data to these computing devices, there is a heavy load on the computing devices. So today there is another technology called as V2X, vehicle to everything. I mean, so it's also called as, you might have heard, vehicle to vehicle or vehicle to infrastructure. So what is happening in this context is we are taking the data from an IoT and also the data that the surrounding environment. I mean, so you can have some hubs on the road, or you can have some receptors on the road. I mean, some signals which can get the data of your car and then give it back to your car. I mean, so that way you are distributing the data instead of only depending on few devices on your car to the environment. I mean, so the environment also is going to give you the data, which makes it little more easier to get the real-time data. Even if something is happening at 1 kilometer away, you could still get that data in advance, and then you can decide how you want to really take a deviation or go somewhere else. I mean, so that kind of things are also possible. So HMI. So HMI is another important concept here, human machine interface. So a lot of today's buyer mentality is, I need that experience. It used to be, I need that feature. Today, I need that experience. I mean, so if I'm sitting inside the car, it has to give me the experience of maybe it's music, or maybe it's giving you an advance notice of, okay, so you went and picked up a coffee from the Starbucks yesterday. I mean, so do you still want to go there and then pick up coffee on your way to office? I mean, so if the car is talking to you like this, that is called as an experience. I mean, so you want that kind of an experience today. So earlier you would put up, okay, so on the map, this is the point that I want to go. Now, car is intelligently tracking all that and then giving you that information in advance, saying, okay, so you picked up yesterday and day before, so do you still want to do it today? So that level of intelligence people want, which is called as the user experience or the customer experience. So a lot of customers are preferring that level of experience today, and so they are not just necessarily depending on the data. Cyber security, very, very important point. Today, the security, because it's depending on the data, which includes your personal data, which includes where you have traveled in the last 10 days, what are all the places that you have visited, where you are going every day, all that information is there. And the updates on your today's cars happen over the air, so which is called as OTA updates. It was taking a lot of time, but with the invent of 5G, that updates are happening at real time for the most part. I mean, so you have to have that updates happening real time. Imagine that session is hacked by somebody. They have access to everything that you have done in the past few days, where you are going, what you are doing. I mean, so they have that full access, which can really become a problem from a security perspective. I mean, so that is where the cyber security plays a very, very important role in really having a fully autonomous vehicle today. So how do we go? I mean, so how do we minimize the perception errors? How do we minimize the prediction errors? How do we minimize the planning and controlling errors? I mean, so this is what we should be focusing on from a fully autonomous vehicle perspective, right? Regulations. I'll not talk about all countries, but we will talk about one country, which is USA. So if you look at US, the federal government has certain regulations for autonomous driving. In US, you have 50 states, and each state has their own regulations. So the regulations that you get from federal are probably a superset of the regulations that you have from state. I mean, so imagine the amount of regulations that you need to go through, right? So today, the pace at which the regulations need to really align with the technology advancement that's happening are not really matching. I mean, so it's catching up, but it's not. I mean, so if the regulations really matter, really come faster, then we'll be able to really close this loop, because each state has. So just for you to let you know, though we have so many states, Arizona is the only place where they allow real-time testing in a controlled environment. So each company has their vehicles, they take there and then they do the testing. Two things happen in that context. I mean, so I just want to cover that. You have seen who is liable. So the slide here. So I'll give you a couple of examples, right? I mean, so Alphabet, I mean, so which was earlier Google. I mean, so they had 16 crashes in the real-time testing environment, but nothing, no fatalities. I mean, so nothing happened. But Uber, when they were driving the vehicle, this happened, I think, in 2017 or 18. So it was having a lot of these LiDAR sensors, and then it was testing fully autonomous. But there was a driver sitting there. I mean, so Uber ensured that, okay, there is a driver also along with this. So vehicle was going, there was a signal, and then the vehicle stopped. And there was an old lady, she was crossing very slowly. And the signal jumped to green, and then the lady was right in front of the car. And the guy who was actually sitting in the vehicle, he was actually browsing something on his Facebook. Okay. And when the vehicle went for testing, because there was a driver, the person who actually gave him the car disabled the automatic collision system, saying, okay, so this guy is anyway there, so he'll be able to control it. So this guy ran over the lady. I mean, the car ran over the lady, and there was a case. Even today, I think it's not resolved. The case is, who is responsible for this collision? Is it the Uber company, or is it the driver who is sitting there and then looking at? Or to the next extent it went to, is it Mark Zuckerberg because he invented Facebook and then this guy is looking at Facebook, right? So who is responsible is really the issue today. In the controlled environment also, the companies, automobile makers, they are taking this responsibility today, saying, okay, so we will test it and if anything happens, we are responsible. But in a real-time scenario, it's very difficult to determine who is liable, and there's a lot of players that are involved, right? I mean, so it need to evolve. I mean, so that is another biggest hurdle from a regulatory standpoint today, that we are not able to move at the pace that we wanted. So what's the road ahead, right? As we were talking earlier, auto OEMs, the suppliers, the chip manufacturing companies, the tech companies, map providers, this is very, very critical. The maps need to be of highest quality and to be rendered at real time, and you can't have a lag on the system. I mean, so it need to be coming. So in India, I mean, so I'm not against India, I'm also from India, but you will go into these no signal zones where you get no signals. I mean, so even if we have 5G, you will still face this challenge. I mean, so we need to have that kind of a reliable networks across the roads where you would be going into these kind of zones, and have those real-time maps, integrated solution providers from a regulatory standpoint, governments, and then the telecom companies. If all these key players in the ecosystem, if all they come together and then really make this a reality, these are all the players that we need to bring them together and tie them together for this to work. I mean, so one alone may not be able to make really a big difference in this context. Of course, I'm from Stellantis, so I'll talk a little bit about Stellantis as well. I mean, so Stellantis is again, yes, I mean, so we are heavily focused on battery electric vehicles and hybrid electric vehicles. I mean, so because our first goal is to achieve carbon neutrality in Europe by 2030. So we would not have any ICE engine based cars by 2030. I mean, so in Europe at least. So, but also we are investing heavily on the autonomous. I mean, so for our level 2 and level 3 capabilities, we partnered with BMW. I mean, so we are working very closely with BMW. For level 4, we have partnered with Waymo, which is Alphabet's company. I mean, so we have partnered with them. And we also acquired a company called AI Motive. AI Motive is very strong in the space of autonomous, and they have their own products called AI Data, AI Assist, AI Drive. I mean, so there are multiple products that they have, which are for various levels of autonomy. I mean, so we are working very closely with them. Actually, we acquired that company. I mean, so hopefully with the 5G supporting us, if we are able to really get this going, we'll be able to really make a difference. What's the way forward? As I said, network infrastructure, supporting 5G. This is mainstream. It's going to be mainstream for autonomous driving. As I was mentioning earlier, road maintenance and management. I mean, so this is a key area. I mean, so we need to have proper lane markings. You can't have so many pit holes. I mean, so you need to have proper road infrastructure for autonomous to work. In India, I mean, so road rage is very common. So you tend to overtake. I mean, so in an autonomous situation, you need to have everybody following some discipline, or all the vehicles following some discipline. If you have a hybrid, and if there is a guy who is drunk and driving and then coming in all over the ways, your autonomous vehicle is definitely going to hit them. I mean, so it's not going to work. So you need to really have that kind of regulations and also the infrastructure. Ecosystem players, I mean, so how all the players that I have shown in the earlier slide, I mean, so how are they going to really collaborate together and then make it a reality? Legislation, I mean, so as we said, I mean, so legislations, they will in the event of a crash, I mean, so that's where they will play a major role. I mean, so these regulations need to really, our Motor Vehicles Act of India is very, very old. I mean, so it doesn't cater to any of these things which we are talking in the AV context. I mean, so it need to be completely revamped if we need to make autonomous a reality. Okay, so in that's where we are today, and I just want to give you a snapshot and also various elements that are involved in this. And yes, it will happen, but it is going at a slow pace, but we will see how it will happen over a period of time. Thank you so much for active listening. And if you have any questions, please feel free. Yeah, exactly. We are also moving away from LiDAR. I mean, so if you actually look at a LiDAR-based car, in a prime minister's convoy, you will see this jammer vehicle, right? I mean, so it looks like that. And nobody would want to buy that kind of a look and feel of a car for their personal drivings, right? I mean, so cameras is the best one. I mean, so that's where everybody is investing today. So is Stellantis. I mean, so we will move on to the camera-based technology, including, I mean, so if you look at some of the cars that we are producing, no longer you have these rear view mirrors. They actually have cameras. So you see that on the central panel. I mean, so who is on the left, who is on the right. I mean, so you don't even need to look this way or this way. I mean, so you can look at the central panel. I mean, so that's where we are also going, sir.
But what I we're getting some time from like ball and the next person next like take a table like an installation of the part. So we told of response time. So that time can do some number what is and what it is now and what they
Unfortunately, I don't have that number. I mean, so, but I can tell you, I mean, we can't even think of microseconds here. I mean, so we need to think of even nanoseconds or even down. Because I mean, see, this is a response that need to go immediately to a braking system. I mean, see, yeah, I mean, I need to get those details. I mean, so unfortunately, most of these data is confidential to the companies. I mean, so OEMs. I mean, so it's not largely shared outside. But I'll try. I mean, so if I can, I mean, so I'll pass on that information. So, I mean, there is a joke that we say, I mean, so any autonomous vehicle, if it passes the road test in India, and that means it can work anywhere in the world. I mean, so, so one, it is about affordability, right? I mean, so take today the EV vehicles itself. Compared to a ICE engine vehicle, EV vehicle costs you almost like another 30-40% more. I mean, so this is the current scenario. So because of which we are not really able to move so fast with the electric vehicles itself. I mean, so today there is a lot of investment that's going in terms of reducing that cost and lower the weight, and then how do we get more mileage. I mean, so today the maximum you're talking about is 200 to 300 kilometers. I mean, so not more than that. So how do we really enhance that? I mean, so that is the primary priority. Imagine if that cost, that itself is so expensive, an autonomous vehicle even will be much more expensive. I mean, so affordability and any manufacturer for that matter, why would they come and develop a car here which has zero sales, right? I mean, so that is where it will take time. I mean, so infrastructure wise, I think there is improvement. I mean, so today, if you see, I mean, so even Hyderabad, we have a lot of good road infrastructure for the most part. I mean, so I'm not saying everywhere, but for the large part. Yeah. See, today, if you actually look into T-Hub, I mean, so our Raju sir is not here, but I mean, so if you look at T-Hub, there are a lot of companies who are actually doing this, but they're doing for other OEMs across the globe. I mean, so they're not. Okay. Very nice. Very nice.
38%.
In the plan they got. Yeah, that's where the cyber issue is, right? Because see, yeah, that is where the challenge is. I mean, so same thing with our website also, right? Same thing with our mobile phone also. So that is where the cybersecurity element comes into picture. I mean, so if we are able to secure that, I mean, so today we can confidently say if you have these protection layers, our systems are 99% safe. I mean, so there could be still that 1% chance of hacking. In an autonomous car, we need to achieve to that level of accuracy. Very high, very high. But you can't compromise on that. That is the key element, because in car, I mean, see, in your system, your networks are even connected. I mean, so you have physical cables and all. Whereas in cars, your updates are on the air. So your session is on the air. I mean, so somebody can really hijack if they really want to. So, but you can't compromise on that element. I mean, so that's the.
And this is 2020, the past 20 years, right now is and the winter there will it's not to be until 2015. I can name some, but there are some companies who have done what is the serious now?
See, that's what I'm saying, right? I mean, see, if you are looking into the algorithms that I talked about, they heavily dependent on the data. And 15,000 kilometers on a real vehicle is nothing. I mean, so the lifespan of a car is almost like 2 lakh kilometers. I mean, so 200 minimum. I mean, so we are not there in terms of getting that amount of data today. I mean, so from a real-time scenarios perspective. In a simulated environment, you can imagine so many things, but it's like doing our unit testing to real testing, right? I mean, so you do the system testing and then deploy the software on the client machine, it will fail, no matter how much testing you do. So that is the exact scenario that we are in today. So it's like chicken and egg. I mean, so without really allowing cars on the road, I mean, how will you get the data and how many scenarios that you can develop? This is the current scenario. I mean, so that is where you are not seeing this vehicle fully autonomous on the road. I mean, so I don't know whether you have seen the Tesla vehicle. I mean, if you get a chance, sit in a Tesla, the new model. I mean, so and you in US what is called as a curbside turns. I mean, so if you allow the car to go, it will be going almost near to that white lane on the left, and you feel as if like it is going to hit that rail. And your BP will shoot up. I mean, so that is how the current scenario is. But that is how it is programmed. I mean, so these are all the things that, as I said, I mean, so that intuition element and replication of the brain into the computer of the car. Our brains are much superior to whatever computer that you can talk about today. Yeah.
So they not use the still not because easily traceable to hijack the
Exactly.
they can't decide exactly the point, but that was the
Self-side goal. Biggest challenge today. That is where the as I said, I mean, so regulations are also not standardized. I mean, so everybody has their own rules. Difficult to standardize also across the countries, different rules. Yeah. Yeah. Yes, sir. That is where we are talking about the real-time maps, right? I mean, if you see the HD maps, I mean, so point A to point B. Even today, you can do that, right? I mean, so if you are looking at your Mahindra vehicle, let's say, Mahindra gives you the GPS. So you put that, it's working on GPS model. I mean, so basically. So
so that you can pick the next. And what will you do?
yeah.
So that or that will invert this in network that in the car.
Sensors are giving you the information to the vicinity. I mean, so like what you can see. But what happens today? I mean, so you are actually set up a Google map. It will tell you saying, okay, if you want to go from Osmania University to Tarnaka, when you are actually making the turn, there is a vehicle that got punctured or there is an accident there. I mean, so traffic is heavy there. You take this deviation and then you go. It will give you that alternative suggestion, right? I mean, so at real time. So because you are operating this when you are getting this real time information. But in an autonomous mode, the map need to get that information from the environment that, as I said, I mean, so the V2X technology or vehicle to vehicle or vehicle to infrastructure technology, and say, okay, so now you don't go straight. I mean, so you make a left and then go right and then make a right and then you will get to the. So that is happening at a real time from the data that is coming from the environment. Yeah, I mean, so yeah, I don't know that. See, because I mean, so I'm not. Yeah, yeah. That's a valid question. So today, I mean, so if you look at even in my company, uh, most of this activity is very controlled environment with highly precise software developers sitting in a few places and then doing it. In India, we are not doing any of that activity, but if you want, I mean, I can do some R&D in terms of what are all the different variables that we need to. But as of today, I don't have that information. Thank you, guys. Yeah. See, vehicle to vehicle communication today is possible. And so it's actually, I'll give you a parallel scenario, right? I mean, so I don't know what is Apple calling this, Apple token or something. So AirTags, yeah. So you know how AirTags work, right? So AirTag is very similar to vehicle to vehicle communication because it actually tracks, it uses the Apple phones, not yours. So you put your AirTag in your suitcase, and then let's say you have left it in US airport, and then you are coming to India, and let's say your bag has missed. If you are checking it, I mean, so whenever it comes in contact with an Apple phone, it will try to leverage that phone's network to send that signal. So that is what is vehicle to vehicle communication is you're talking about. So that is feasible. That is actually available today. Okay. So thank you guys. Thank you for active listening.
So I would like to thank all the participants who come to attend this session at College of Engineering, Osmania University, and also to those who are watching online on the YouTube broadcast. In fact, the session was very lively, and also the technology that is for the future for all of us is really promising. I think there are avenues of lots of innovations that are needed to be done, not only from companies but also from the education sector, where the students are having a fresh brains, they have a lot of energy, and they're very good in thinking of new items out of the box. So therefore, there is a collaborative effort required from industry, academia, and also the faculty members to see that this technology comes as a boon to the human mankind in the future. Certainly, there is always a debate in the country is saying that is it safe to have autonomous cars driving on the roads? There is also a second school of thought saying that if you look at the number of accidents that are being happening on the roads, if you look at the percentage of accidents that are happening, maximum percentage is because of the driver's negligence, because of driver being either drunken, or if he is sleepless, if he just blinked his eyes. So therefore, if you can avoid the driver, and if the car is driving on its own, technology cannot go wrong. If you look at the number of percentage of errors that are happening because of human errors and autonomous cars, very few accidents happen, and there is a lot of hue and cry. The people who don't like these autonomous cars, they are saying that it's not correct. But if you look at compare the percentage of accidents that are happening because of autonomous vehicles and because of human errors, there is a huge divide. A very, very minor fraction of accidents happening in autonomous cars when compared to the actual cars because of human errors. So let's see. Let's hope that this technology comes into the uh, practical use, not only in other countries but also in India, so that we are all driving safely in the Indian roads. So thank you very much, Mr. Rahul. I request Professor Chenchak Reddy garu, Head of Department, to come over and present a token memento from our college, university, and also the SAE Hyderabad division side. And may I also request Dr. Gurraj to join us. Camera. Thank you. Thank you all. Close.
Streams.